Yes, I guess everybody has joined.
Okay. Good afternoon, everyone. I'm Anisha Bose. I warmly welcome all of you today in this research reading sessions. This is our second day. On the first reading session, Xuan model presented a paper on the role-aware multimodal federated learning system for detecting phishing web pages. Before we begin with today's session, I would really like to take a moment to extend our heartfelt congratulations to Professor Obijit Kain, Shayan Mondal, Bhanu Berier, Dr. Khokon Mondal, and Dr. Umshuman Jana on their full paper acceptance at IEEE Region 10 Symposiums. This is a remarkable achievement and a matter of great pride for all of us. Congratulations, sir, and best wishes for your continued success. So now coming to at today's session, we have an exciting and highly relevant paper titled Landscape of Thoughts, Visualizing the Reasoning Process of Large Language Models. It will be presented by Sayak Naskar. Xiao is a very passionate AI and technology enthusiast with strong interest in artificial intelligence, NLP, and intelligent reasoning system. He combines research-oriented thinking with practical technical understanding and enjoys working on innovative real-world technology problems. Professionally, he has worked with the leading organizations including Tata Consultancy Services, TCS, Deloitte as an SDET, where he gained a valuable exposure to corporate environments, technology-driven problem solving, and professional collaboration. Now he is pursuing his master's degree at IIIT Guwahati alongside his professional experience. Xiao actively explores modern AI systems, machine learning, prompt engineering, and intelligent agent architectures. He is particularly interested in understanding how advanced AI technologies can be applied in practical and meaningful ways. He is known for his analytical mindset, technical curiosity, and ability to communicate complicated ideas in a clear and structured manner, and continues to focus on learning, innovation, and building impactful technological solutions. We are delighted to have him today in this platform to share his insight on this paper. Without wasting much more time, I would like to invite Mr. Sayak Naskar to begin with the presentation. Before he begins, I would like to let everyone know that we will provide a feedback form at the end of the session. Please fill that in so we can have the smoother communication. Thank you. Over to you, Sayak.
Yeah, thank you, Anisha, for your kind words. So, now sharing the screen. Can anybody take that same visible? Is my screen visible and am I audible?
Is Sayak you visible and audible both?
Okay, thank you. So, good afternoon, everyone, and welcome the second reading season of the MindSpec research community. So, today I will be discussing a very recent and honestly a very intellectually exciting paper that is titled as Landscape of Thought, which visualizing the reasoning process of large language models and was that is presented at ICMA 2026. So before starting that, let me tell you that now over the last 2 years or a few years, we can say that we have seen reasoning models evolving extremely rapidly. Systems like OpenAI, O-Series, or the DeepSeek R1. So they are no longer just simply generating the text. They are also solving critical mathematics, real-world writing codes, producing proofs, production level deployments, and sometimes even they correcting themselves during the inference. And naturally, this creates a deeper scientific curiosity as well. So when these systems actually generate a long chain of thought reasoning, what is actually happening here? Are they uh, genuinely reasoning? Are they exploring the possibilities, or like they just gradually gradually converging towards the answer, or sometimes they are simply just generating a statistically conclusive lab. So these are the multiple possibilities we might favor happen. So this paper actually tries to answer that the question in a very unusual. So instead of reading or listening those traces manually, let's attempt to visualize the reasoning itself. Actually. So this title itself is actually very revealing landscape of, and I think the wording is beautifully academic because This paper is essentially proposing that the reasoning can be viewed as a movement of through a landscape. I would say it's not just a statistic text or not just a isolated token words, but rather it's like trajectories that moving through a progressive belief space. And this idea actually comes from the researchers across like HTB, Stanford's, and Mela. So which already tells us the paper sits at the at the intersection of the reasoning systems and the representation analysis. So one thing I personally find particularly interesting about this current large language model research is that these strange imbalances between the capability and the understanding still persist. We are rapidly improving the reasoning performance day by day, but our understanding of how this reasoning unfolds internally, that is still remains the limited, surprisingly. And the most interpretability tools today that also focuses on total level behaviors like the attention maps, activation proteins, neural circuits, and many more. So those methods are useful, of course, but the authors make a very important observation here. A single token that does not contain the result, it emerge. Uh, Actually, it emerges across sequence of evolving thoughts that interpret it or that interact over the time, and it creates what the paper calls as a thought level interpretability care. So, if I want to say, in other words, if I say that we can inspect the microscopic computation sector, but we still struggle to observe uh, observe an entire reason trajectories. So moving before moving it further, let's understand or let's familiar ourselves with what the trajectories is. A trajectory is nothing but just an essentially it's a path that the model takes while things step by step towards an answer. Okay. So today, debugging and reasoning the systems are still surprisingly primitive, and researchers literally read trajectories manually. So let's consider a couple of ideas or examples. So the 30 seconds per trajectory may not sound large initially, but once we start generating thousands or hundreds of thousands of trajectories during iterative development, this process becoming impossible uh, in scaling. And even more importantly, this interpretations becomes subjective. Also, what we author observed that different researchers may derive different kind of conclusions from the exact same reasoning phases. So the paper essentially asking, can this reasoning analysis becomes systematic instead of just subjective? Can we study the reasoning behavior scientifically rather than just merely reading the outputs step by step? Now we are at the first glance. This problem may sound easier than it actually is. So author identified three major challenges while looking this problem statement. The first challenge is the token thought abstraction gap. So existing tools, as I have already mentioned about the existing tools, now I'm getting into it. Existing tools analyze the tokens while reasoning, it unfolds at the level of thought sequence. The second challenge is accessibility. Many frontier models today are almost closed source, unlike ChatGPT, paid versions like API6, and expose very limited internal information. So any practical framework should ideally work the post-op without requiring any training data access, right? And the third challenge is perhaps the most subtle, but the accuracy. And this alone tells us that whether the final answer is correct or not. But the thing is, it tells us almost nothing about how the model arrived here. Did the model hesitate or it just explored the alternative approaches? or it just collapsed on the early stage. So this this behavioral information is invisible, so it will be only look at the final answer. Now we arrive at the conceptual nature of the paper. The author also proposes a surprisingly elegant idea, and this idea is like at every intermediate reasoning gap, the model is already learning what the certain answer that others. It means every thought implicitly occupies a position relative to the answer space. And personally, I think this is where the paper becomes genuinely beautiful because one thought becomes the positions and the reasons becomes a geometry. So the model is no longer like simply generating the text. It is actually navigating through a belief of landscape. So naturally, the next question will be like, how do we mathematically formalize this idea? And the setup is here is based on the multiple choice of reasoning task actually. So the model like it generates multiple trajectories, and we can consider these trajectories as T1, T2, T3, and so on. And every reasoning state, the framework analyzes the current reasoning state. So importantly, this landscape thought is completely post-op, and it neglects the intervals during the reasoning itself. So it only observes and analyzes the trajectories afterwards. And I think this is a very important design relation about how it keeps the framework model agnostic while it still reveals the reasoning dynamics actually. Now we arrive at the mathematical heart of the paper. The author represents every reasoning state using a perplexity based feature vector. And uh, informally, this perplexity measures how surprising the model would be a particular this continuation. So after every reasoning state, the framework evaluates how the compatible each answer option is with the different kind of reasoning state. So if an answer has a lower perplexity, so the author states that the current reasoning aligned are also strong with that answer. And by computing this across all the candidate answer, then thought becomes the structured numerical representation. And this is the most important moment where the language transforms into a probability distributions. So once these feature vectors are generated, so the author projected them into two-dimensional using t-SNE. And this is where the paper becomes a visually compelling because the reasoning trajectories like comes with more visible. Correct trajectories gradually migrate towards the correct answer anchor, and the incorrect trajectories it's totally drift towards the misleading regions. Some trajectories also remain the exploratory, some also prematurely collapse and scatter diffusely. So this is for the first time. The reasoning is no longer just hidden inside the text. So we can actually uh, observe its structure evolving visual across the different dimensions or across the different time. And this visualization reveals several fascinating behavior patterns. Incorrect trajectories tend to follow smoothly towards the correct answer region, and the incorrect trajectories either wander diffusely or it's confidently converts towards the incorrect regions. But perhaps the most important findings is like early divergence. And the correct and incorrect trajectories also often separated within the too few reasoning steps, which means the quality of reasoning that becomes detectable surprisingly in the early stage. And that is something vocabulary interpretability methods struggle to capture. So now the paper validates this observation across multiple model families and the benchmark data sets as well. So thousands of trajectories are analyzed across reasoning heavy tasks, and the contribution becomes quite substantial. So the paper introduced a couple of things here. The first one is thought level reasoning abstraction, perplexity-based state representation across question comparable landscape, automated reasoning metrics, and the scalable reasoning diagnostics. So this is not like merely a visualization paper. Rather, it's proposing an entire new way of analyzing the reasoning system. Actually, the paper also introduced three quantitative metrics, which is the consistent uncertainty and the perplexity. So, and these all together matrices provide the complementary provides windows into the reasoning quality. So, the consistency it also measures whether these intermediate states align with the eventual answer. The uncertainty measures how the distributed the model's belief remains, and the perplexity. This measures how we expect or the surprise the reasoning state itself is actually. So the framework becomes both geometric and the qualitative analysis. So these experiments are actually quite comprehensive. The authors actually evaluate the multiple model scales ranging from the 1 billion parameter to 70 billions of parameters. They compare this several reasoning paradigms also like chain of thought, tree of thought, least to most reasoning, and the Monte Carlo research. And importantly, they evaluate across multiple datasets involving the common sense reasoning, algebraic reasoning, and the multiple reasoning tasks. So these conclusions are not just limited to one model or one benchmark actually. Now we arrive at one of the first major discoveries. So as the model size increases, the geometry of the reasoning landscape changes dramatically. So this the smaller models produces actually high scattered and unstable trajectories. But compared to the large models, I mean they produce much cleaner and convergence behavior. And this is the fascinating actually because this capability itself becomes the visually observable, and you can almost watch the intelligent emerges through the convergence dynamics. Now, this is where the paper becomes genuinely counterintuitive because we associate the confidence with the intelligence. We assume that the stronger reasoning will the faster convergence. But this paper actually discovered almost the opposite because the incorrect trajectories frequently becomes the confident and extremely um, early stage. They collapse towards the wrong answer, giving the first 20 to 40% of the reasoning state. So the correct trajectories actually behave differently. They remain exploratory longer, they hesitate sometimes, they continue evaluating alternative regions before actually converging near the end. And honestly, I think this observation is philosophically interesting also because it's genuinely good reasoning often requires the sustainable uncertainty before its clarity emerges actually. One thing I personally found very interesting is that the framework behind, framework begins with the revealing not only whether the reasoning succeed, but also what type of reasoning actually happen in the background. Different task produces completely different kind of geometric sequences. For an example, datasets like AQAE, MMLE, or strategically keyway. So this dataset generates broad exploratory landscape. The trajectory here spread out and explore multiple regions, gradually organize themselves through different deductions. But one thing authors observe that common sense theory behaves very differently. This landscape become tightly concentrated almost from the beginning. Because why? Because this is common sense task actually often rely more on direct knowledge rather than just multi-step logging exploration. And I think this is a very powerful observation because now the framework is no longer just merely evaluating correctness, rather it just becomes the characterized reasons style itself. So the paper then compares different reasoning paradigms: chain of thought, tree of thought, list to most reasoning, Monte Carlo research. And what is fascinating is that each of these models leaves a distinct geometry footprint inside the landscape. Sometimes this method explores aggressively, or sometimes it's stabilized. Other converges rapidly, but the risk premature commitments here. And once again, the same universal pattern appears. Incorrect trajectories often converge faster than the correct. And I think this is extremely important because this traditionally we compare reasoning methods mainly through a benchmarking accuracy. But now this paper gives a way more study opportunity on reasoning dynamic themselves. Now we personally no I personally I think this is the most exciting section of the paper because the author analyzed the reasoning specialized model, which is a TW 32 bits parameter, 32 by millions of parameters. So this model actually occasionally generates reflective based statements like, wait, let me check it. So now, normally we read those as a plain text, but landscape of thought reveals something much deeper here. So those self-correction moments it's become the geometrically visible one. This trajectory actually literally moves towards the wrong answer region, then again pauses, and then again started redirecting itself towards the correct region. So this self-correction is no longer merely linguistic behavior; it becomes a spatial behavior. And honestly, this is a remarkable shift in how we think about the reasoning systems. At this point, the paper would already stand as a strong interpretive contributions, but the author also take the idea on one step further. They ask actually, can these reasoning landscapes become the predictive features themselves? And to test this idea, they built a lightweight verifier system. This verifier system takes a landscape of thought features and consistency scores as an input, and it predicts whether a trajectory is trustworthy or not. And importantly, this idea does not require expensive human annotation. So the model is trained using only a very small amount of data. So the paper transitions from the visualization towards the practical reasoning evaluation. And surprisingly, this verifier platform remarkably well. It consists improves the reasoning accuracy across multiple models and reasoning methods. So the gains are especially significant for the smaller models, where the baseline reasonings are bigger. And what I found particularly elegant is that the verifier itself is extremely lightweight. So no additional LLM is used, just a random forest operation on low dimension reasoning features. So this result strongly suggests that the landscape contains meaningful predictive structure, not just visually interesting patterns. This section actually connects very naturally with the recent discussion around the time-space scaling. Normally, simple genetic mode trajectories eventually it reaches the diminishing finish. Majority voting started with the surprisingly quickly saturated, but this verifier guided application it continues improving the performance significantly. And I think this has a broader implication for the future design systems because it suggests that the smarter trajectory evaluation may matter more than just brute force computation alone. So, in other words, if I say this reasoning quality becomes more important than the reasoning quantity. So, one of the strongest practical finding in this paper is like transferability. The verifier trained on one dataset can still improve performance into another dataset. And similarly, a verifier trained on a large language model can still help the smaller models. And this is the important because it suggests the framework is uh, learning structural properties of a reasoning dynamics rather than just memorizing the superficial dataset patterns. Of course, not every transfer is work perfectly. Sometimes the combination remains the neutral, or sometimes it's slightly negative. But the overall result is like strongly suggests that the reasoning landscape captures something fundamentally giant mindset. Like now I also appreciate that the paper discusses its limitation very honestly. Currently, the paper or the framework, I would say, primarily work for the multiple choice task question answering because it requires the answer anchors. It also like it depends on open source models with low probability access and computationally it's extracting all the reasoning states that introduce the noticeable overhead. But importantly, these are the mostly practical constraint rather than conceptual limitation. The broader framework itself remains extremely powerful. And honestly, I think the future prediction discussed here are extremely exciting. The author talk about that extending landscape of thought towards fully open-ended reasoning tasks, trajectory pruning, hallucination analysis, safety monitoring, and even detecting the rationalization behavior. So one particularly interesting idea is identifying trajectories where the model commits to an answer almost immediately, and then it's merely generates the decorative reasoning afterwards. And I think this has strong implications for the trustworthy AI systems and the interpretability research moving forward. So this slide actually position the landscape of thought related to the existing interpretability or the verifier approaches. So the traditional methods like attention maps or the probings, it remains a token level. And the process reverse models, it also requires the human annotation, which is quite expensive. Also, the self verification methods often lack of scalability or the learnability. So the landscape of thought, it's entirely operates differently. It works at the thought level. So that is why it does not require human annotation. It remains the scalable across the reasoning trajectories. And I think this higher level abstractions is perhaps one of the paper's most important conceptual contribution. Now, naturally, an obvious question arises here: how do we know that these landscapes are meaningful and not simply just artifacts or the dimensionality reduction? And the author here addresses these concerns quite thoroughly. They validate the frameworks across multiple projection methods, including t-SNE, UMAP, PACMAP, etc. And they test different tokenization different sample size, different model families, and different reasoning parameters. And importantly, these quality patterns that remain stable throughout the experiment. So the overall, I would say, I think this paper contributes three major things. First, it introduces a scalable framework for visualizing the reasoning trajectories. Second, it reveals several fascinating observations and about the reasoning succeed and fails. And third, it demonstrated that these trajectories features can actually improve reasoning system through lightweight verifier mechanism. So this is not just an interpretability for the visualization, rather it becomes an uh, interpretable of actionable reasoning analysis. So I think this slide captured the entire philosophy of the paper beautifully. For years, we have trained the large language model to reason step by step, right? But we have mostly been reading their outputs like static text. So, what landscape of thought gives us something closer to a map that of belief dynamics, a map of like convergence behavior, or like we can say that uncertainty, exploration, and some kind of self-correction map. And once the reasoning becomes geometry, so this entirely new possibilities as like trajectory verification, hallucination detection, safety monitoring, trajectory pruning, and deeper like interpretability research. So personally, I think the most beautiful aspect of this work is like it's not merely about the visualization technique, but it itself the framework itself. And and the perspective also shift to introduce how we can introduce in the real world. So like now this section is like particularly useful during the discussion because for example if somebody asks why the paper useful the perplexity instead of embeddings. So the key idea is like that the perplexity it directly reflects the model's own generative belief distribution. If someone asks about the t-SNE reliability, so the paper actually explicitly validate uh, the finding using the alternative projections method like UMAP, also PACMAP. And if someone argues that the framework only works for multiple choice tasks, so the author also already discussed about the extension using the pseudocode operations for the open-ended reasoning. So the overall the paper is actually very careful in defending its methodological choices. And I believe this paper is important not only because it introduces a new interpretive framework, but because it actually changes how we conceptually reasoning itself. So instead of like treating the reasoning as a static text generation, we can frame the reasoning as a dynamic navigation through a probabilistic population landscape by using this landscape of thought. And honestly, I think that uh, perspective could become more extremely influential for the future reference systems, and also it can more verify architectural and interpretability research. So, yeah, thank you everyone, and I am open to open for the question discussion and research conversation.
Thank you, Xiao, for the insightful and engaging presentation. I hope today's session has been informative. Now, if anyone has any question, please feel free to ask the speaker. We want this session to be interactive. If anyone has any question, please feel free to ask him. And we also have some question in the chat box. If you can refer them also.
Uh, uh, Before starting this question and answer session, I definitely say something. Um, uh, Students, those who are actually not much aware about this kind of means, research, and they are might be in a very fast state in their
just started, they might have not much of knowledge of this kind of thing. So what I ask that I definitely tell them to follow the session properly and don't feel that you are asking the silly questions. This is the platform for entirely for you. Okay. So I think that whatsoever the question is coming in your mind, just listening the topic from the speaker, you definitely ask the question. Okay. This is the request to everyone. So interact accordingly. Okay. Now, I think I have some question, and definitely I will ask the question later on. But before that, I think Xian have some questions. He will be asking that question. I think it will be better.
Yeah, I'm just taking one by one, sir. Which
Yeah, yeah, definitely, definitely.
So, what is trajectory and how it does help in generating accurate answer? So, trajectory, as I mentioned earlier, it's a like full of sequence of reasoning state for a problem. Right. So, let's start with like state one, state zero. Okay, the question only. So, it grows as each thought T1 is like generated like A0 to S1 to S2, and it's going to sequence to S1, S9. Okay. So it helps the accuracy via the verifier. This state actually features from the trajectory encoding convergence speed plus the consistency. So here the verifier actually trained on these features with better trajectories higher than just majority voting, which helps to boost the accuracy. And it also especially with more trajectories like in the paper it's mentioned 65% versus 30% of saving with with the more accuracy. So the second,
Mikhail, for the better clarification, is it that the trajectory you mean, let's say, for example, if you are using some particular AI tool where we are basically putting some prompt and getting some answers out of it, and it's a multiple time you actually put the different prompts and to make them make your machine to understand what better, what exactly you want to know from the machine. Is it that the questions and this kind of chat you are calling is a trajectory or something else?
trajectory, sir, is essentially the path the model takes while thinking step by step towards an answer.
Okay.
So you are using chain of thought, right? Let's see step by step, right? We are writing that format. So in that case, model will start. We'll go through a path to find out the answer, and that path I'm referring here as a step by step. What's it? The
Okay.
path the
Yeah,
model takes while thinking, thinking about it.
that means you are telling that if the prompt is given, how the particular answers of that particular question, what we basically float over there in as a form of prompt, how this particular answer is being generated, that path is you are calling as a trajectory. Is it
Yes, the
so?
thinking step. Yes, thinking step.
Okay. Okay. Thank you. To go on for the next questions.
So, is there any possibility of modeling this work from geometric perspective? So, it is already geometric. Like for each state, it's mapped to like a different dimensional probability syntax. Okay. So the answer also here it choices like fixed vertices, landscape vertices. So if I say the trajectory means the path of those kind of syntax actually. So it's nothing but the distance to vertices. Then again, it's entropy of the coordination, sometimes the speed of movement towards the correct vertex. Is it noticing?
Well, I my question is a little bit of different. Means I means you have basically given some slides over there. I have seen that the geometricals means like a map. It's over there. Okay, means your trajectory, how the path of the trajectory follows. Okay, so is there any option means is there any point where actually we can think that this particular trajectory can be modeled in a from the perspective of the geometrical computation? It's a computational geometry we can say, where the geometry is being used for the computation purpose. Means, there is a very well known thing is there, convex all. The people work on that, use these particular algorithms for the different kinds of classification and any many other purpose estimations. Also, they do that one. So also, I suggest that if anyone is interested to learn this particular thing, computational geometry, how it can be used in this particular this particular model, what exactly you have basically presented, that also be a point where we can look into. Okay, okay, you carry on.
Third question from Sharon. Why do wrong words converts faster to wrong answer? So that like the paper does not give a casual mechanism. So but I mean they interpret it like a wrong paths lock into a plausible, but incorrect answer actually I mean there is a terminology plausible but incorrect answer. So that actually surface the pattern matching or it's the heuristic shortcuts. So no genuine multi-step reasoning actually needed. So the model itself is like jumps and it corrects the answer required actually the computations here. So it believes that like the distributed longer before the committing and the here the author states that like early commitments means shallow the reasoning signal. Is it clear, Shan? Shan?
I think he might be not able to listen that one properly. So you carry on to the next question.
Okay, so in that case, let's assume we have a many more wrong reasoning path. Is number of wrong reasoning path is much more greater than the right reasoning path, and in that case, our graph is
Sorry.
okay.
Shan, your voice is cracking. Can you please write the question in the chat box so that Shai can understand properly?
Last one, right?
Okay,
So if the wrong question that's coming is hard. So it's very long.
okay, 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 okay. I'm getting that.
Do you want me to answer? Okay, I'm answering actually. So like here we use I mean the researcher uses the verifier. That verifier uses the state features. Okay. And there is a consistency scores that computed the intermediate states. So it's not just like at the end it is using, but it's using the midpoint in the tree of thought and Monte Carlo tree search. So you can score a partial trajectory here. So the wrong path shows like low consistency and the path convergences towards one answer early. So this is called as a like pruning. And the correct path shows like distributed it is distributed like belief. It also the high uncertainty mid trajectory and it also shows the slow convergences. So that is why it survived there. So like the early exploratory means like almost never a false positive for the pruning. And the signal is like the asymmetric signal here. Is it okay now?
I think it is okay. You just go forward to the next question.
Okay, so next question is like so
Try and ask the question from slide number 19. If the random forest verifier is trained on only 20 questions, how can we trust that is generalized to the new data set, model or reasoning method? This is his question.
um,
It will be better if you just show the slide number 19 and answer the question.
So this. Okay. So like, uh, let's think of it like this. The verifier is not like learning what the answer is. So it's like a learning tool how good a reasoning path looks like. So it's asking about does it stay uncertain long enough or does it commit only at the end of the answer? So and that is the reason it shapes the good reasoning, uh, whether the answer is about the math, history, or the science. So here the 20 examples is enough to learn the pattern, not just the content about it. So, and that is what it's proven that friend of that one data set, AQUA. So that improves the strategy. That is another data set that improves the strategy level more than 4.5%, and it also trained on the 70 billions of parameter. So it still improves 3 billions model by 5.5% in the answer. Is it okay, Shan? And I think sir, you have also another question, like ethical.
I have the last question actually. Means, this is an ethical aspect of LLM. Is how the trajectory reacts on the illegitimate questions. Say, for example, uh, how to develop an atom bomb. Okay. Or let's say, for example, how to break the jail. Okay.
So paper actually does not test this particular question directly, but the logic applies here is like if a model is safety aligned, and then it automatically reviews or hedge on like 100 questions, and it believes it stays scattered. So landscape of thought would show a chaotic, not just like the convergence landscapes. Right? So this paper explicitly mentioned about the future application using landscape of thought to monitor jailbreaks, attempts, and safety alignments by watching the abnormal trajectories pattern. So yeah,
Well,
it does not actually taste this directly. Actually.
yeah. So I definitely tell this particular paper is very thought provoking, and idea is very good one. In this particular after this particular reading session, what exactly we can do? This is not only for this particular session. I uh, definitely ask everyone to do in that way. If you actually feel this particular paper is relevant to your research work, definitely go through again this particular paper and interact with the speaker as many as time is you require to interact that one, and definitely that would evolve over the period of time some good research questions, and we might be addressing those questions again and to do some very good work out of it. Okay. With this particular comment, I thank you, Sayak. This is an excellent presentation, what exactly you have done today. So I also thank you to all other team members, those who have basically made this possible to happen this particular reading session every week with a perfection. So I thank them also. Thank you very much, and I hope our MindSpec lab work will get a great success in future. Thank you very much. And we'll be waiting for the next session that would be on next Saturday. And the speaker name and all those details of this paper will be floated in the website soon. Thank you. Thank you very
Thank
much.
you, sir.
Thank you,
Thank you,
Xiao.
sir.
It was an excellent presentation. Very easy to understand, and the slides were all really good. I hope students will go through it again. And we also hope to listen to you again in future. Thank you for this excellent presentation.
Thank you for your kind words.
One more announcement, very important one. I need that some of the students actually asked me in the last week also that how they can get this slide. Okay, so we need to make some provision for the students so that actually they can go into the website and download it, some from somewhere else. Okay, so that this particular thing will actually be available to them. They can further read it and everything. Okay, I understand the in YouTube they will get this lecture, but this PPT also they require. Okay, I asked the development team so that they make this thing possible, but this particular thing will be available in the website too. Okay, thank you very much to all of you.
Thank you, sir. Thank you, Xiao, for this presentation, and thank you all the participants who have joined and gave their valuable time in this presentation. I thank all of you. So everyone will be provided with a feedback form. Please fill that form so that so it is easier for us to make the session more easier. With this, we have come to the end of the today's session. We hope to see you again in our upcoming research discussion. Thank you, everyone, and have a pleasant day ahead. Thank you.
Thank you. Thank you, everybody.